What we want to think about is a few things, right? We want to think about first derivative, second derivatives, and sort of general features of our curves as well, right? So for example, this one over here, if I'm looking at this, okay, let's go find first and second derivative, because that's sort of the easiest part, right? So first derivative, something like this. Second derivative, something like this. Okay, so far, so good. How is that going to help us curve sketch? The sort of most notable features of a curve are its minimums and maximums, but also their inflection points. So we can go ahead and do that. But I sometimes like to think about also what's going on in terms of a big picture. Like, I guess the issue is you don't know what a quartic really looks like, right? You don't really know what kind of shape that's going to have. Yeah, so it will, I mean, that y equals to x to the 4, for example, that was just like that. But when you start adding in these kind of things here, you can sort of change them, right? I mean, what other features of curves do you guys usually look at when you think about like curves in general? X and y intercepts. So I usually tend to start with those, even though we've been dealing with calculus and things like that. Just because when I start to put this together, I kind of want to go from a big picture and then zoom in to what's going on, right? So we can do that as well. So let me get rid of... How should I do it? So let's draw it over here. And we can say, okay, 4 x and y intercepts. Let y equal to 0. And how can we solve for x in this case here? Yeah, nice. Factorize. So we're going to have 2 of them. So x equals to 0 or 4. And then 4y ints. But x equal to 0 and... Oh, that's not very interesting, is it? So that's kind of where we're starting to form our graph. We've got 0, we've got 4, and we know that that's the only y-intercept there, right? So far, so good. So this is where we're going to start to put the mins and max together now. When we do this, right, so this one over here, so we do this in the same way. So let y dash equal to 0 for stat points, and this is my sort of abbreviation for them. Abbreviations I do be careful with because sometimes they can be misinterpreted, but you know, in the exam situation, I understand if you want to save a bit of time or when you're doing the exercise. And again, we'll take Ashley's advice, we'll factorize here. You have two solutions, either when x squared equals to 0 or 4x minus 12 is equal to 0. So this one is Aiden's favorite. X equals 0, nice little solution there for us.
Can you take in the 4 out as well to make it easier?
Yeah, you can do that, that's a great idea. So let's do that. And what's that going to be, Felicity? Yeah, nice. So again, you're going to love this part. What comes next? Table. Yeah, but, now this is the thing, right? When you're doing curve sketching, right, you typically want to find the second derivative because you're looking for the point of inflection. So now you sort of have another option, and this is going to depend on the situation or depend on the question. But sometimes it may be easier to actually consider, okay, well, if I have these 2 points here, and I actually have the second derivative, what can I do in order to test, right? Well, I can use these properties here, right? I can say, okay, what's happening, for example, when I check at x equals 0, what's happening with my second derivative? If I check x equals to 3, what's happening with my second derivative? That helps me classify. Can you see that? So rather than drawing the table out each time for both of those, because that's actually quite time consuming, what you can do is you can just substitute them in and go from there, right? So let me show you what I mean by that. So you can say at x equals to 0, you can say y double dash is equal to 12 times 0 squared minus 24 times 0. So y double dash equals 0. And so what do you know about that? What does that tell us?
It's a point of inflection.
Or It's a possible, yeah. Okay, so possible with no inflection. This one though, hopefully that will give us some more interesting results. So we can say at x equals to 3. Someone can calculate that for me. 36? Okay. So, if my second derivative is greater than 0, we know that there is a minimum at this point. So therefore, min at 3, what's 3 4? Sorry? Oh, negative, is that the final coordinate? Yeah, perfect, thank you. Would you say that's how would you compare that to the table method? But a bit faster, yeah. So I think it depends on the question. If you've already found the second derivative anyway, it's a bit quicker than substituting things in a table. Some people like the table because it's sort of easy to do, you're just substituting. I would say this probably is a bit quicker though, provided as long as you can remember the properties correctly, right? And try and think about it visually. If it's concave up, then it should be a minimum there if it's a stationary point, right? We're not quite done yet, so we've got some points, more points you can fill in a moment. We can kind of just make a note of those for now, right? But we need to now look at the points of inflection. So let's do that over here. Let's go with, what have we got? This guy. Josh, you had an abbreviation for points of inflection. What was it?
POI.
Okay. What else could POI be?
Poi.
You said poo.
Point of intersection.
For yes, so that's kind of, yeah, just be a little bit careful. Like, I would assume a mark would be good enough to know that, yeah, they're talking about points of inflection. Just kind of be careful. Could be point of intersection, could be, yeah. So, that's why I tend to stay away from abbreviations, but that's just me.
I'm not writing point of inflection every single
I completely understand, I completely agree. But just to make a note of that. So what have we got? 12x squared minus 24x equals 0. And again, same idea, we'll factorize that. This one though, because we're not going to take the derivative again, we will use the table method as well. Yeah? So x equals to 0 or x equals to 2, and we will have to test both. Okay, cool. So, what did you guys get for this one? So these are 0. Who's got numbers for this one? Yeah. Perfect, that's what we want. Yes, nice. Okay, and it's good that we got some numbers we can reuse as well. So, what can we say? So therefore, point of inflection, or POI at, that one was 0, 0. So that one, and there's a POI at 2, 0? Is that right? No, that's not right. What's the point of inflection at? Negative 16? Yeah, that's right. So how do we put this all together, right? We've got a lot of pieces here. We know that min, I've already put that in, and what I tend to do is I try and write a little bit of indication of what's going on. Minimum may look something like this. We know it has to pass through this point, it has to pass through this point. And not only does it pass through this point's actually a point of inflection, right? And again, you can kind of get an idea of what's happening. It's a concave up and then a concave down sort of situation. The other thing that I haven't talked about is, okay, I know that there's all these parts here, but what's going on is a big picture thing. What's happening at the extremities here? And what you can do for that one is if you test, for example, I'll just finish this off, right? Caitlin, can you put in like 20 into this equation here, the original curve? And Lily, can you put in like negative 20? 20 for that one. So if you test really big x values in other ways.
Positive.
Yeah. So what's the y value when you put it in?
When I put it in as 20, it's
Yeah.
128,000.
So what does that mean?
It's a large positive.
Yeah, so when it's an x value over this way, it's kind of like this. Can you guys see that? And Lily, what did you get when you put negative 20 in? See that? You get a positive 2, so that's fine. So because it goes in that direction that way, right? So it's just to give us an indication of what's happening at the extremities. You substitute in really large x values in the positive and negative direction, and that's going to tell you what's going to happen. To finish it off, and I'll do this next lesson,
It'll be like a screw.
but we know there's a point of inflection here, so it's going to be concave up to concave down.
And then it's going to
And it's going to do it again at where? 2, negative 16. Not the nicest numbers, but that's alright, we'll roll it. Something like this. You can smooth it out a bit later on. And then what's going to happen after this? Let's go straight up, yep. And if you graph that on Desmos, it will look in fact something quite similar to that there, okay? That's just a bit of a taste of curve sketching. So that was a little bit rushed, but now you have enough to do 6.0. We skipped 6.0 and 4 and the other classes as well, because we won't be examining that.